to go over all of your homework from last night, 4 out of 7. And then I'm going to also talk about 4-8 today, okay? 4-8 is very simple. It's finding all the angles and all the segments of a triangle, of a right triangle, okay? Finding all the segments and all the angles of a right triangle. That's 4-8. So I'm going to spend the bulk of my time today going over 4-7, make sure everybody has that done and we understand it. So the first thing we need to talk about is understanding the arc sine, arc cosine, and arc tangent. Domain is -1 to 1. For sine and cosine, for the tangent, it's from negative infinity to infinity. Yay. The range is from -pi/2 to pi/2. For sine, for the arc sine, it's going to be from 0 to pi. And then for the arc tangent, from -pi/2 to pi/2. Now, what I want to do is I want to make sure that you understand what you're doing on all these. So if we're looking at problems 1 through 6, did anybody have any problems with problems 2 through 6? Come on. Which one?
Just take one.
6. Somebody read it to me.
Arc cosine.
Arc cosine of -1/2. First of all, what you need to understand is -1/2 in between 1 and -1. Is it?
Yeah.
Yes. What am I doing there? I'm checking to make sure that number's in my domain. Do we understand that? Very good. Now, the next thing we need to talk about is we need to say, okay, well, what is the range for my output for my lovely little cosine, my arc cosine function? We just talked about here, what's my range? 0 to pi. If it's from 0 to pi, that means I'm going to be in these two quadrants. Yes? Now, it tells me that the cosine is -1/2. What quadrant am I forced to be in? I am in quad 2. Do we all understand that, yes or no? So I want to know the angle that lies in quad 2 that has a -1/2 as its cosine. Well, that's going to be, if I was in quadrant 1, that would be a pi/3 angle, correct? So what's that going to be in quadrant 2? 2 pi/3. That's going to be 2 pi/3. Do we all understand that, yes or no? That's A. B. B says to do the arc sine of the square root of 2 over 2. Well, again, if I'm doing the arc sine, what do we know about that? Is the square root of 2 over 2 in between -1 and 1? Is it? Yes. If you don't know, you need to go ahead and you need to type in your calculator. Yes, it's in there, so I know it's in my domain. So now I need to come over here and I need to think quadrant. Well, what is the range of sine? Arc sine. -pi/2. Yeah. So -pi/2 to pi/2, that puts me in these two quadrants. Now which quadrant am I actually in? Why am I in quadrant 1? Because it's positive. So now that I know I'm in quadrant 1, I need to find the angle that has the square root of 2 over 2 as my lovely little sine value. And that's going to give me pi/4. Does everybody understand how to do that section now? We good? Page 311. Page 311.
Copy.
Just copy the extra. Page 311 is the blue box.
Yeah.
That is page 311, I promise. Right? You with me? Okay. All right. Now, are we good on number 8? We talked about yesterday in class. We showed how to graph that thing. And when to complete the table? Yes. So we should be good on that one. Number 10 is exactly the same way. Number 12. How many of you struggle with 12? 12 is not as hard as what you think it is. First of all, they give you this graph. Who cares? What do I need out of that graph? It tells me that I'm graphing the arc cosine of x. And then it gives me 3 ordered pairs. So what's the first ordered pair? -1, and then I don't know. What's the next one? And I don't know. And what's the last one?
You don't know, and then pi/6.
I have 3 separate problems here. My first problem says, this is my x coordinate, these are my y coordinates, so I'm going to plug it in. Y is equal to the arc cosine of -1. My second problem is going to be y is equal to the arc cosine of negative 1/2. And my third problem is going to be y is equal, no, not y, pi over 6 is equal to the arc cosine of x. Do we see that? I have 3 problems there. So all you have to ask yourself is -1 between my -1 to 1. Yes, it is. So what angle has a cosine at -1? Pi. I understand that. So my answer here is pi. What angle has an arc cosine of -1/2? Keep in mind the range is from what for arc cosine? 0 to pi. So what angle from 0 to pi has an arc cosine of -1/2? It would be 2 pi over 3. Because I need to be a quadrant 2. What angle? Well, it's not what angle because they give us the angle, right? So how do I get rid of the arc cosine? I can't divide by it, so what do? Multiply by cosine. So the cosine of pi over 6 is equal to the cosine of the arc cosine of x. What happens to the cosine and the arc cosine? Those cancel out, and I'm left with the cosine of pi over 6 is equal to x. So what is the cosine of pi over 6? Answer the clock. Square root of 3 over 2. Square root of 3 over 2. Do we understand that? Yes or no for number 12? It was very simple. It wasn't a big deal on that. Just 3 separate problems. Can someone close the door, please, so that the light doesn't take off right in my classroom? Repeat.
I don't understand like how you would know like why pi.
Because cosine, arc cosine goes in between 0 and pi, which means I have to be in these 2 quadrants. Well, if you have your unit circle in your head, the only place that there's -1 is either at 0, pi over 2, or pi, or 3 pi over 2. It falls on your axis, right? In order for it to be on my x-coordinate, it has to fall at the value pi, because that is the value, -1, 0. Okay? Okay, the next set of instructions for 13 through 24. You needed to make sure that you were putting those in your calculator. We had no problems with those, right? The next set of instructions, 26. 26 was very simply, it wasn't a big deal. It simply wanted you to graph this thing. They wanted you to graph the sine of x. So if I graph the sine inverse of x, I get this. Okay? Then they wanted you to graph the sine of x. So tab, trig, sine of x. But when I graph the sine of x, it gives me the whole function. I want to cut that function. Now, what is the range of the arc sine? -pi over 2. Well, the range of the arc sine would be the domain of the sine function. So I need to go back here to this, and I need to restrict that. So I'm going to go to control equal sign, and I'm going to grab the such that symbol, and I'm going to make that -pi divided by 2. Control equal sign is less than or equal to x. Control equal sign is less than or equal to pi divided by 2. What I'm doing there is I'm restricting my domain. I'm telling this thing that I want to graph all of the x values that are between -pi over 2 and +pi over 2. Do you understand that? That such that symbol is going to make it so that it's giving you that domain restriction. So when I do that, this is what I have, and you can clearly see it now. I'm going to zoom in a little bit here, just so that it's nice and clear there that you can see it. Okay, well now what's it saying it wants you to do? Well, then it's also saying that it wants you to graph y equals x. So I'm going to hit and type in another graph in there, which is y equals x. And what is it asking you to do is compare and contrast that. Well, what's happening to that, folks? It's clearly reflected over the line y equals x. Do we see that? Well, isn't that a property of being inverse functions? That's all it wanted you to do. Do we all understand that? We good? What do you write down to that? Well, it says, use the graph utility to graph the function. We did that in the same view window. And verify, graph geometrically, that G is the inverse of F. Be sure to properly restrict the domain. What do I want you to write down, Nick? I want you to write down the restricted domain, first of all, on the sign of F. Why? Because then I know that in your brain, you know how to restrict the function on the graphing calculator. Okay? Then in addition to that, I want you to tell me that there are reflections over the line y equals X. Okay, 28 and 30. We talked about those yesterday, how to write an inverse function. Are we good on those? You should be okay. What I want to talk about is 38. If we talk about 38, is the sine inverse of the sine of 7 pi over 4. Now, what do you guys instinctively want to do here? Cancel out. So if you want to instinctively cancel those out, let's talk about that a minute. We have the sine inverse of sine of 7 pi over 4. I'm going to show you two different ways to think about this. Your brain has to think like this. What is the sine of 7 pi over 4? It is going to be in quadrant 4, which means in that quadrant, I'm going to have positive, negative. I'm talking about my sine. That is actually going to be the sine inverse of the square root of 2 over 2. Yes? Now my question to you is the square root of 2 over 2 in my domain of the arc sine? Is negative 1 less than or equal to square root of 2 over 2, which is less than or equal to 1? Is that a true statement? Yes, this is a true statement. Since that is true, I can calculate this problem. There is a solution to this problem. Now the next thing is I want you to ask the question, what is my range of the arc sine? What is the range of the arc sine? I need to be in between negative pi over 2 to pi over 2, which means I need to be in where? I need to be between there. My question to you is 7 pi over 4 in between is that a true statement? Is the decimal equivalent of 7 pi divided by 4 in between negative 1.57 and 1.57? In your calculators right now, I want you to give me the decimal equivalent of 7 pi divided by 4. It's 5.49. Is that a true or a false statement? This is a false statement. Do we understand that? Because that's a false statement, it is in the correct quadrant. But can I find another angle in that quadrant that would have exactly the same sine and arc sine value? Yes. I cannot use 7 pi over 4. So I cannot simply cancel out the sine inverse and the sine, can I? Do we understand that? If I go back to the original problem, I cannot do that and say my answer is 7 pi over 4. Do we all understand that? We good on that now? And the reason why is because of the statement right down here. If you put that in numerical form, you can clearly tell that that is not going to give you the correct answer. So how do I find that? We have to find the coterminal to that. So that's going to be 7 pi over 4 minus 8 pi over 4. Why am I doing minus 8 pi over 4? Because minus 8 pi over 4 is 2 pi, and that's going to give me my negative pi over 4. Do we see that, yes or no? Now, is negative pi over 4 in my interval?
Yes.
Clearly it's in my interval, so therefore this is my answer. Do we get that, yes or no? Are we good on that? Did you understand step by step why it's equivalent to that? No one's left out the cold. We're all good, right? Excellent.
Okay. Negative pi over 4 is going this way.
Nope. This is negative pi over 2. This is pi over 2. Okay? That means negative pi over 4 is right here. That means positive pi over 4 is right here.
But your range is pi over 2 pi over negative pi.
What I want you to do is take the circle, snip it, and make it a line. Okay? That means everything to the left, meaning the negative angle opening clockwise, right, is to the left of 0. Everything that's positive, meaning opening counterclockwise, is to the right of 0. You with me? Okay? Snip that circle, put it on a number line, and what are you going to get? You're being confused with the positive, negative, right? Clockwise, counterclockwise. Okay. Let's go to the next concept here. 4-7, we're still in. And let's talk about problems 39 through 46. 39 through 46. Let's do 44, shall we? Let's do 44, shall we? Okay, 44. It says to do the tangent of the arc sine of what? Negative 3 over 4. Thank you. Okay, what did I tell you to do yesterday? As soon as you saw that you had two trig functions going on there, what did I tell you to do? I told you to grab that u concept, right? So that means I'm going to say, let u equal the arc sine of negative 3/4, meaning the jump inside the front. Are we good? Now, what I want to know is if we're talking about arc sine, we have to first figure out, is negative 3/4, is that a true statement? Is negative 3/4 in my domain? Are we good? Absolutely. That's a true statement. And the next thing we need to talk about is the range. What is the range of the arc sine? Negative pi over 2. Pi over 2 is what we're talking about for the range of the arc sine, which means my answers have to fall in these two quadrants, correct? Yes or no? But it says my sine value is negative 3/4. What does that imply? Which quadrant am I in? I'm in quad 4. I'm in quad 4, which makes a lot of sense for me right now, because that implies that my angle, I have a triangle that looks like that. Do you see that? I have a triangle that looks like that. Is my radius ever negative? No. So if I look at this thing, this is going to be, how do I get rid of the arc sine, folks? So I have the sine of u is equal to negative 3/4. Because if I take the sine of both sides, that cancels out the arc sine of the sine, correct? Which means, negative 3, we have opposite over hypotenuse. Where does the negative go? Does it go with the hypotenuse, or does it go with the opposite? Why does it go with the opposite?
Hypotenuse is never negative.
Hypotenuse is your radius, guys. Do we understand that? Yes or no? We good on that? So with that said, we're going to have my... There's that. We're just going to throw in our radius, or our angle there. If I do that, I'm going to have opposite, which is going to be negative 3 there. And is that correct? Should that be correct there? Did I put my theta in the right spot? Think of your x. That means x is negative 3. Well, x is positive in that quadrant, right? That means it has to be the opposite place. That means this is theta, this is negative 3, and this is 4. Does everybody understand what I just did there? I have to still go with that concept of my positive negative. That means my x is positive, my y is negative. Do we all understand that? Okay? So now what do I need to find here? I need to find my last side. So how do I find my last side? A squared plus b squared is equal to c squared. So that's going to give me negative 3 squared plus b squared is equal to 4 squared. B squared is going to be equal to 16 minus 9. So b is equal to plus or minus the square root of 7. Which one is it? Positive square root of 7 or negative square root of 7? Why is it positive square root of 7? Because it's on the x-axis. Do we understand that? So b is going to be positive square root of 7. That's what's going to go right here. Do we see that, yes or no? Okay, well now, what is u? What's this jump right here? What's that jump? What do we call that jump? So what I'm actually calculating is the tangent of u, right? Well, do I have u here? This is u. Theta is u, correct? So how do I find the tangent? This is going to be opposite over adjacent. So opposite is -3 over adjacent, square root of 7 to give you -3, square root of 7 over 7.
I did this right, but I didn't take like the last step. Put it back in to
Do you
get.
understand it now?
Yeah, I just didn't put it back in to get the tangent out of it. But I did everything else.
Okay, we did a problem like this yesterday, and we did a problem like this today. Now, what I want to do is get you started on tonight's homework, okay? Do we feel like we understand 4-7 pretty well now? Good. Okay, tonight's homework. Chapter 4-8, written A, 2 through 36, even. 2 through 36, even. We're going to jump right into the homework. And the reason why we're going to jump right into the homework is because the homework is application problems, and it's just given triangles. How do I find it? How do I solve for it? Biggest thing you need to understand, folks, this is the biggest thing, the most important thing. If I give you a right triangle, C always is the right angle. Why? I don't know. They always labeled that to be the right angle. This is going to be A, and this is going to be B. Capital letters indicate angles.
The angle opposite of the leg or hypotenuse is it'll be lowercase for hypotenuse. It'll be lowercase c for hypotenuse.
Yeah, but that's not what I meant. I meant they could have chosen A to be the right angle.
Yeah, but the right angle is always opposite the hypotenuse. And the lowercase c is the hypotenuse, right?
Yes, according to A squared plus B squared equals C squared. Yeah. But they could have chosen a different letter if they wanted to. It's just a different formula, but it's still the same concept. Okay? Now, capital letters are your angles. Lowercase are your segments. Lowercase are your segments. Now, how do I place my segments? Your segments are always across from the angles. Always. So, segment B is across from angle B. Segment A is across from angle A. Segment C is across from angle C. Do we all understand that, yes or no? That is the way it always is. It doesn't matter how you place your triangle, how you order it. Okay, that's always the way it is. Do we understand that, yes or no? We're going to start right with the problem, number 6. Things that you need to know. A, B, C, angle A, angle B, angle C. I haven't looked at the problem. This is what I know I have to find. I have to find every single thing inside that triangle. Do we understand that? This is exactly the way your test will look. I'll give you a triangle, I'll give you blank spots, and you have to fill everything in. Well, what they give you is that side A is 25, side C is 35, and angle C is what? 90. That's the given information. Do we all understand that? Now you have to find everything else out. Now how do I go about finding everything else out? Well, I'm going to simply just draw my triangle. There's angle C, angle A, angle B. This is going to be 25. This is going to be 35. What I don't know is going to be letter B. So how would I find letter B? What's hanging in here? You know how to find that, correct? I'm not going to worry about that part. I want to find the angles. So how do I go about finding the angles? Well, what do I know? If I want to find angle A, what is 25 according to angle A? Opposite. What is 35 according to angle A? Hypotenuse. Now, David, what did you just say this was? The sine of angle A is going to be equal to the opposite leg, which is 25, over the hypotenuse, which is 35. Now, how do I get rid of the sine? How do I get rid of the sine? I can't divide by sine, so what do I have to do? Right. are we doing this the last section? It was in first.
Sign and negative 1.
So I need to do arc sine. Those are gone, and that's what angle A is going to equal. Now everybody get their calculators up and type this in. Now, if I type in sine inverse of 25 divided by 35 and hit enter, it gives me this decimal. What are my angles in? Degrees. What type of answer is that? Radians. So what you want to do is you want to click on your battery, come over here to settings, go to angle, and turn it to degree. And now everything in here is going to be exactly the same. Arrow up, hit enter, and what do you have? 45 degrees.
You just treat it as a function. You cross multiply with sine A. Now sine A equals 25.
Oh,
Yeah.
Can you go back to A times 35, like sine A times 35 equals 1 minus 25?
No, because you got to find an A. Sine of A is attached to it. So how do I get rid of the sine? I have the arc sine. Every time. You have to isolate A. You're thinking in proportions to finding lengths and finding the angles, and you can't do it like that. To find an angle, you have to use the arc sine. Do we all understand this? Yes or no?
You want us around that?
Yeah.
So just leave
2
it
decimal
as
places.
small, 2 decimal places.
Actually, let me check here. Do they run 2 decimal places?
Where's my other times?
They go to 2 decimal places on everything. Lengths, segments, and angles are 2 decimal places. Now, if I know that this is 45 point, what was it? 5.8. Can I find angle B?
Yeah, 45. Oh,
You're going to take 90 minus 45.58. Right? We all understand that. Okay? All right, any questions over what I want you guys to do the rest of the time?
That's all you do on that.
The rest of this is all application. That's all it is. The rest of it's all application. Okay, I want to see how you guys do on this.
How do you find B?
I might actually be
Yeah,
good.
you do the whatever.
Side B? Put that right there. Okay, you guys are on your own.